Okay. Oh, it looks like it's 1 o'clock, so we'll go ahead and get started. Thank you for being here. All right, so this week, the only thing we have to cover is section 6.6. And so the plan was to have like a class activity on Wednesday. So let's look at problem number 4, since it's the only one in this list that's still available. Okay, so at first they want us to calculate 16.8 divided by 0.35 to the hundredths place without a calculator and to show our work. Okay. Please just interrupt me if you have any questions. All right, so the first thing we're trying to express is the ignoring the decimal. The way that we ignored the decimal in decimal multiplication was by ignoring the decimal in both values and calling them both whole numbers. This time, we use one of them to guide how many decimal places we ignore in each of them. Okay, so in terms of the standard algorithm, we would write 0.35 divided into 16.8. And we would ignore the decimal in terms of making the divisor a whole number. So we have 35. And I usually write 2 arrows as a nod to myself that I'm then moving the decimal place 2 places in the next number. Sorry. I'm going to write something and take it away. So I don't like to leave this notation, but it kind of helps you see where you're going to put the 1, 6, 8, 0. And then the decimal place gets locked in right there, becomes part of the form. And we don't even acknowledge it ever again, right? So at this point, they said that we need to find this value to the hundredths place. That means we can put trailing zeros in here. 1, oh, that's the eraser, wrong thing. Okay, 1, 2, and then to find the hundredths place, we need to go 1 digit further. Okay, now the ignoring the decimal place has occurred, right? And a lot of times you or your students will just do it right where it sits, but that gets clouded when you're the one presenting the idea, right? So you're showing why the idea works, how the idea works, what the idea is, right? That's our job. And so here we have ignored the decimal places, making the whole number, making the divisor a whole number. And then as a result of how many places it took us to make the divisor a whole number, we use that to move the decimal place of the other value, right? The dividend. So just as a reminder, so vocab, we've got the divisor, That's the one doing the dividing. The dividend. I'm sorry about all the coughing. And that's the one being divided into. And then the answer, that's the quotient. And each of those values alone is the divisor and the dividend. But when you see them together with that symbol, you're looking at the quotient. So they'll just call that expression the quotient because it represents whatever the answer represents, and the answer is the quotient. Okay, so just the vocab. Okay, now when we divide, right? Now we're just whole number dividing in the long division format, and we're gonna play the long game, right? So we look at the first digit. This time we're looking at the first digit to the left, and we say, how many groups of 35 can I make out of 1? And you're like, none. So in our algorithm, we say, okay, so we skip this number, right? And now we look at the 16. We look at this whole value 16, and we're saying, how many groups of 35 can I make out of 16? And again, you say none, right? And then we skip that value and we look at the 168 and we say, how many groups of 35 can I make out of 168? Okay, so that's how the algorithm goes. And I did this already beforehand. I found that to be 4. So 4 groups. I can make 4 groups of 35, and that is 140. And then I subtract those for the value of 28. Now, how many, just as a double check, can I get any more groups of 35 out of 28? No, that's good. That means I can go on to the next place value to the right. We say we bring down the 0. So some people actually physically bring the 0 down, like arrow to it down. I think that helps some people keep the place values in order, especially if you ever get a no in the middle and move on, right? So now we ask ourselves, how many groups of 35 can I get out of 280? And it occurs to me now that 280 is twice 140. If we got 4 groups to get the 140 and we double that, 8 groups will get us to the 280. I took a little trial and error, but now that I'm doing it a second time, I can see a different pattern, right? So, okay, so 48 with nothing left over. And then I was like, uh-oh, did I do this wrong? Because it told us to find it to the nearest hundredths place. So then I checked it in the computer, and it was just 48. So the answer is a whole number. If you want to give it to the nearest hundredth, just in case you're scared you're going to be marked wrong, then we can do that. And in that regard, we would be saying, bring down this 0. We still don't make nothing. Bring down this 0. Still can't make no groups of 35. Bring down this 0. Still can't make any groups of 35, right? And then you cut this off, evaluate whether or not you want to round. You don't. So your answer is 48.00. I would just say 48. I stopped at 48 on my own. Okay, so now we have to try to show other aspects of what's going on here. Like, why didn't we go back to the original drawing and move the decimal point around, right? Like what's happening with that? Because in multiplication, when we ignored the decimal point and multiplied whole numbers, we had to argue how to get back to the original starting point. But division, we're going to show that we don't have to go back, because in fact, these two expressions are the same thing. So let me write down what I'm eventually going to try to say. That's that. Let's see, we've got two of the three forms of writing. So I'm going to do it fraction form now. We're saying 16.8 divided by 0.35 is, eventually we will show the same as, the exact same as this value, as in they're the same value, they're equal to each other. So we don't have to go back, they're the same thing, right? So we want to show that. Now, we've calculated without the calculator, we showed our work. We described the standard procedure for determining where to put the decimal point in the answer. You lock it in this location. We set that up as we were describing going to this second visual here. And now we're going to explain in several ways why this answer is correct. I put it in the calculator just to make sure, but now we're going to show in other ways other than the calculator that we are sure. And you don't have a calculator on the test, right? So you definitely want to know more than one way to do something, right? So let's clear this out. I've got a couple of different ways written down here, right? One of my favorite ways is like the improper fractions. I do it slightly different than the book does it, but I can try to show you both. I was thinking, let me see, let me grab their version too. Okay, so I like to write it like this. So let's do an improper fraction. Argument. Okay, so you always start them at the beginning. For me, you are the them, right? So I have to start you at the beginning. But for you, it's your reader or it's your students, right? It's whoever you're presenting this information to. Start them at the beginning, which is the same equation the book gave you, 16.8 divided by 0.35. And now I'm going to write an improper fraction, right? But I'll go slow. So let me just space this out for a second. And one thing we described was letting the 0.35 control the whole number that we ignored the decimal point to, right? So on the 0.35, we would need to multiply by 100 in order to ignore that decimal and treat that value like a whole number, right? That's our control mechanism right there. As a result, we aren't trying to change anything. So we actually want to multiply the top and the bottom by 100. And what we do to one value, we're going to do to the other in this example. So we're going to also multiply this one by the magic number 1 in the form of something over itself. In this example, 100 over 100. In the next step, I'm then going to multiply the numerators and have these two denominators. So I get to the 1680 stage, divide by 100. And the 35 divided by 100. Now, we'll show in a second that this expression here, in terms of the definition of fractions, number of pieces, size of piece, is the same as that first expression we wrote down, 16.8 divided by 0.35. So some algorithms have you say, once the denominators are the same, once the size of the pieces are the same, you just care about the number of pieces. And so we could just divide 1,680 by 35. I'm going to take you through the keep, change, flip algorithm, the invert and multiply, so that you can see cancellation, right? So we have the 1680 over 100, and now times 100 over 35. So in our algorithm now, we're going to cancel those hundreds, one on the top, one on the bottom in multiplication. And we get to the 1680 divided by 35. So I want you to know that we started with this expression. We walked through equal signs, which means we said, this has the same value as that. This has the same value as that. This has the same value as that, until we got to the end. And we have this expression here. So we're showing that the 16.8 divided by 0.35 has the same value as 1,680 divided by 35. We showed it using an improper fraction. So that justifies why we don't move the decimal point back, because the two expressions we wrote down are the same value. They have the same value. So for part B, we then have justified ignoring, or like why we are able to leave the decimal point where we do. Okay, so let's see, or even part C, right? Sometimes I don't. See. I think we did part B when we talked about the two arrows over and all of that kind of stuff. So we showed ignoring, basically. Okay, so this is part of part C, but we showed that when we went from expression 1 to expression 2, we didn't need to go back because these have the exact same value, right? So these are equal, we've shown with this improper fraction. Okay, so we're gonna show two ways. I think, or maybe we're still gonna express it in a few ways, right? So whether they're actually showing ways or not. Let's see. So we showed that. Another way to explain why the placement of the decimal point is correct is to use that like size argument that we had. Okay, so this one's a little different because it's division, right? But just to start playing around with it, right? We have that 16.8 is larger than 16. So this is a size argument. We're arguing by size. Okay, so we've got that 16 is less than 16.8. And then I did both just to play around with the numbers, right? And then the 0.35, let's see, that's bigger than a 0.25, and a 0.25 is a quarter, right? We could use that if we wanted. And we've got here that we have something less than a 1, right? Because we're really trying to go for whole numbers, except the 0.35 would round down to a 0, and we don't want to use that number. Okay, so in terms of like dividing these two values, then you have to flip the signs actually, and I'll show you why, right? Because of the answer. But we've got a 16 divided by a 4th on that side, right? And we've got a 17 divided by 1 on this side. And so the quotient on the easier side is 17, right? If we use the keep, change, flip algorithm, we're really doing 16 times 4, which is, let's see, a 64, right? And so you can see that the 17 is on the less than side now. So when we combined these and did the division, we flipped the signs that we were working with. But we're trapped between a 17 and a 64, right? And we had 4800 as an answer if you considered the extra zeros we were supposed to come up with, right? If that matters for this argument. But if it doesn't matter, then you can see it's the 48 itself that's between these, not a 4.8. That's too small. That's less than the 17. So definitely not a 4.8, which is less than the 17, right? And then you wouldn't want to go 480 because that's bigger than 64. So the 48 itself is the answer that's trapped between the 17 and 64. I did it too close, and I did a third right there, and I got the exact answer. So for you all, I tried to use a different lower value so that I got an actual range there. But we did show that 17 is less than the quotient. And the quotient was less than 64, I think it was. Okay, so that was a second way by size that we showed the placement of the point was valid, right? Now, a couple of other perspectives, not perspectives, that's not the right word. What is this perspective, right? So is this how many groups or how many units in a group situation, right? Like we have these two different ways of looking at division. And so I've definitely been articulating it such that we're looking for the number of groups, right? And so if that's true, then we could be looking at this in terms of money, right? So like we could say how many groups of, I call it 35 cents like this, but the book always calls it 35 cents like this. So how many groups of 35 cents are in $16.80? Right, that's one way of looking at it. So you've got this bus money, and it costs 35 cents every time you get on the bus. So how many times can you ride the bus with your $16.80? We showed through previous work that you would be able to ride the bus 48 times, right? This is one way of trying to visualize it for yourself, especially in terms of decimals, right? Okay, another one's the base 10 drawing. They're going to have you refer to figure 622, but I encourage you to use the base 10 shorthand unless you're actually going to commit to using graph paper and doing it to scale. Otherwise, just use the base 10 shorthand. So another way of being this situation is to use our base 10 shorthand. So every time you use base 10 shorthand, you have to use a key, right? So base 10 shorthand, and then we need a key. We are trying to divide two values. The smallest place value here is a 0.001. 0.01. There you go. So that's the smallest place value. That's your unit. So in our key, we have circles. Those are called units. We have a long, it's called a long in some books, it's called a rod in others. Then we've got the flat. And I didn't leave very much space for it. I'm gonna, oh, maybe I can fit it down here. It won't let me draw below there. We've got, this is bad, hold on. Let me just move it to the back. The next shape, we would have a cube. Okay, so that's the shapes. And now we're going to fill it in. We've got the smallest place value as our unit. 10 of those is a rod. 10 of those is a flat. And 10 of those is a cube. So it's always sometimes nice to remind the reader that relationship. I don't think I pointed very far. Sometimes you're the reader, right? So sometimes it's notes to self, right? Okay. Now, we would want to say, how many rod, circle, 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 circles are in, I kind of crunched it, but we'll get it, are in a cube. Six flat. And 8 circles. Question mark. So that's how to write it in base 10. And now if we were in person and we had the ability or the desire to actually do this, what we would do in reality, like if this was us at work breaking boxes down type of thing, right? And we had to make them in this orientation where you're putting out 3 groups of rods and 5 groups of units, then what we would do is we would take that cube and break it into flats. We don't need any flats. We'd take all of our flats and break it into rods because we need rods. And then we would take some of the rods and break them down into units so that we could try to make groups of rods and units that look like this. And then that's what we would put out, right? And then as we put that out, we would count out how many groups we got as a result. So we definitely know how many are in a group, right? So this is like number of items in a group. And this stack over here, this is the total number of items. So you're again trying to view this, at least I'm emphasizing again the how many groups perspective or interpretations. How many groups interpretation? Okay, so let's see if I've hit everything on my page there. And then, okay, so a couple of tie-ins. Pretend instead of just stopping there at breaking these shipments in down to the flats and then down to the rods. Pretend instead we broke it down to just units, right? We took all of the boxes, all the cubes, all the flats, and we broke that down into, oh, I think those are supposed to be rods. And we okay. Sorry about that. I just noticed those are supposed to be rods. 1, 2, 3, 4, 5, 6, 7, 8 rods. Okay, let me fix my notes. I don't know. No one's ever going to look at them again. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so the conversation still holds. We would break down some of these rods into units. We break down everything into rods and units. But what if we kept it going until we broke everything down into units, right? And we just had the individual units sitting out, then we would have 1,680 units, and we would have trying to group them in sets of 35, right? And so what I'm trying to get you to kind of picture is then the argument where we were at before when we talked about 1680 hundredths being the same as our 16.8. Okay, so we just came from a screen where we had units and the units were 0.01, right? We often change this to a 0.80 for our convenience because we were trying to divide by a value that has 2 place values after the decimal point, and we need that location, right? So when we see these 2 values being divided, we can also view that as we saw as just 1680 divided by 35, right? We saw that and saw that those are equivalent, right? And if we break the last image down until those rods and flats were just these units, then you would be able to see this relationship as well, where we didn't care about the pieces anymore once they were all the same size pieces, right? So here in fraction vocab, once we have the same sized pieces, we just care about the number of pieces. Which is the second component here. Okay, so just a little refresher, then the definition of fractions. Oh, it's not D on top, is it? Okay, so we've got numerator over denominator, numerator being number of pieces, denominator being size of the piece. And we showed with base 10 the size of the piece. Okay, so they're going to have you do this with like 7/8 and 3/8, but the argument is still the same. The pieces are the same size, and so all you care about is the number of pieces at that point. So let me clear this one out for a second. Your homework is whole numbers. No, that was whole numbers too, but like, let's do a different value, like a 5/8 divided by 3/8, right? Okay, so if you define a whole, and you don't probably even have to do this part, but you know, so if this is a whole and this is an eighth, then 5/8 divided by 3/8 is asking how many of these, trying to line it up right underneath of the guide that we wrote above. So how many of these are in, and then try to get 3, 4, 5 of the ones from above. And if you can, for the consistency factor, try to get them lined up so people can see what you're trying to say. And how many of those are in this? So you can see where once we have the same size pieces, we don't really care what size they are. We just need to know how many of a set of 3 can we get out of this set of 5, right? So here we've shown or tried to show that 5/8 divided by 3/8 is the same as 5 divided by 3, because we don't really care about the size here. Okay, let me see. And then we should try to write a word problem for it. That's one of your tasks, right? Is writing each type of problem. So we're not going to think about the drawing right now. We're going to think about the two different types of division problems. So start with your definitional multiplication. A times B equals C. A is your number of groups. B, your number of units per group. And C, your number of units total. Okay, so we're going to write two word problems, one for each interpretation of division. One interpretation being how many groups, and the other being how many items in a group. How many units in one group? That's how your book words it. So we have to word it like them. Okay, now let's put some units on here so that we've got words, right, to try to construct a problem around. We know that the 16.8 is going to go in the C position, and the 0.35 is one of our factors, right? And so if we commit to the money example, we could call C a quantity of money, and we could call B a quantity of money per. We used bus ride earlier, right? So we could commit to that one. And we were asking how many bus rides do we get? Because we already wrote this problem. We said, I have, or whoever, John, right? I have 1680 on my bus card, right? The bus costs 35 cents to ride. How many times can I ride the bus? Right, so we use that as an example to try to get our brain around the money example anyway, but we have been enforcing that particular style of division each and every time. Now we're going to try to change the numbers up on ourselves. So I don't think I'm going to use bus rides anymore because I would need a whole number of bus rides maybe for it to make sense to me, right? And we know we had a whole number of groups, so it fit. But this time I'm going to use like pounds maybe in money, right? Because pounds we can have a decimal amount of, and money we can have a decimal amount of. So on B, I'm going to ask like how much money per pound style of question. Okay, so let me bust out the eraser. And we'll try to put words to this, and then I think we'll pretty much be done. I'll check it real quick, but here's B then, in terms of some words. So we could have, let's see, we need our 16.8 in place here and our 0.35 in place here, right? So we have bought 0.35 pounds of, I'm going to say, chocolate covered cherries. And we spent $1, or I wish, $16.80. How much were the chocolate covered cherries per pound? Question mark. Okay, so that takes us to the alarm bell ringing. Hopefully I set you up for all of your homework questions. If you have any questions though, please let me know. We'll just do class activity on Wednesday. And so come with questions for sure about your homework on Wednesday, and we can discuss those, any of those that you have. But thank you so much for coming to the Zoom today. Thank you.
I hope you feel better. Thank you.
Thank you. Bye.
Thank you. Thank you.
Thank you.